Hey y'all, I'm gonna go through graphing of cosine. So last video was a little bit long, I know, but a lot of you said it was helpful. I graphed sine, and with sine I graphed the vertical stretch and also the horizontal shrink. So I did the vertical and horizontal shrink stretch, and then today I'll review how to graph the basic cosine curve, and I'll graph the horizontal translations and vertical translations. So we'll start with cosine, and as usual I'll break the quadrant into I'll break the x-axis into the 4 quadrants. Okay, so we have 2 pi, pi, half pi, and 1.5 pi. Okay, and then you can make your y-axis whatever you want. I'll just do. Okay, so again, if it's helpful, you can have the little unit circle next to you, and so you have your points 1, 0, 0, 1, -1, 0, and 0, -1. Okay, and cosine, of course, is the x value. So my usual reminder is x comes before y, just like c comes before s. So at 0 radians, cosine is 1. And so we've been talking a lot in class about how you can recognize cosine versus sine based on where they're starting, and typically cosine will start on the y-axis unless there's some sort of horizontal change. So we'll look at that for h of x. Okay, so I have 1 at pi over 2, I'm at 0, so in quadrant 1, positive, right? And then in quadrant 2, we go to negative, so we have down to -1. Quadrant 3 is negative, and then back to +1 in quadrant 4. Okay, so that's our f of x, which is the standard cosine curve. Okay, and then just like I said in the sine video, you can use your standard curve, the parent function, the parent cosine, to graph the other one. So if we look at g of x, we'll think about where do we normally start cosine. So we'll start at 0 radians, it's at 1, so the point 0, 1. And so I'm gonna go down 1, so I'll take that point minus 1. And then I'll go to the next value, which is pi over 2, and at pi over 2 the value of cosine is 0, so I'm going to take 0 minus 1. And then at pi I have the point pi -1, so then I'll go down 1 from that. And then keep moving around so that we get all of the points 1 unit down. Okay, so remember, this is happening to the function. If it's happening to the function, then we're moving vertically. Okay, so it's some sort of vertical movement, and then you can just connect your points. Okay, and so we'll label that as our g of x. Okay, and then we'll lastly graph h of x, and then we'll review quickly the period, amplitude, frequency. So if we look at h of x, in this case, it's happening to x, right? So since it's inside the parentheses, this indicates that it's a horizontal translation. So we're going to be moving left or right, okay? And so normally we have cosine x minus h. So in this case, our h is the pi over 2, which means we're moving to the right pi over 2. And then just as a note, we can always confirm our stuff graphically, and I'll review how to do that at the end of the graphing. Okay, so normally I start cosine at 1, but I'm moving to the right pi over 2. So that means I'm going to start it at 1 at pi over 2. So this becomes like your new starting value, right? And so then pi over 2 moves over pi over 2, so that goes to pi. And then pi goes over pi over 2, so that's like 1.5 pi. And so normally, so I'm considering the red one, right? So normally at pi I'm at -1, so then I'm gonna go to -1 there. And then at 3 pi, I'm usually at 0, so I'll graph back there, okay? So we have a good idea of like what's happening when I move it over, and then we'll kind of go from there. So now, if I think back to the negative values, so if I'm thinking like negative quadrants here, at negative pi over 2, which is the same as negative 90, it's at 0. So that means I'm just going to slide over 90. I'll be 2, 0, and so then I'll put it there. Now remember, we said that sine and cosine are pretty much the same graph, just under a translation. And so if you look at the blue graph looks a whole lot like the sine curve, okay? And so remember, these all have the same values, just 90 degrees difference, or pi over 2 degrees difference. So this is our h of x, okay? And typically I would say that the horizontal translations are always the most challenging, so you kind of want to double check and verify that the graphs are accurate, okay? So for each of these, our period has not changed, okay? So for all of these, the period is the normal period, which is 2 pi. The only thing that changes the period is if there's some number in front of x, and none of these have a number in front of x. So for all of them, the period is 2 pi. If there's a number in front of x, then the period would be 2 pi divided by that number. The frequency, remember, is the reciprocal of the period. So we have one curve in 2 pi. And then we would look at amplitude, and the amplitude for each of these is consistent. So all of these are going to have the same amplitude. Remember, amplitude is the distance from the midline to the maximum, or the distance from the midline to the minimum. Okay? And so in this case, the amplitude is 1. It's always a positive number because each of our functions has only a 1 as the coefficient of cosine. Then we have our midline, okay? And the midline for f of x and h of x is y equals 0 because there's nothing being added or subtracted. For g of x, however, my midline, the middle of the graph, moved down to -1, and that's y equals -1. Okay. Remember, the middle is halfway between the max and the min, so that would be our midline. Okay. All right, so let's quickly review the graphing so you can check it. So open a graph page, and then we'll go to trig, and we'll graph cosine, and we'll graph cosine x so we can see the basic function. And you can hit enter, and then we'll go through the process for fixing. Notice my window, -10 to 10. I'm in radians, okay? So I'm going to go to window and zoom trig so that it'll put me in from 0 to 2 pi, or actually from -2 pi to 2 pi. And then it has my graph. If you'd like, you can also adjust by hand your window settings. So if I wanted my y scale to be, by ones, I could do that. So like -5 to 5. So then I can kind of see what's happening. Okay. And you notice it does say 0.5 on the y scale. So if you wanted that to be just by single units, you could do that as well. Okay. Now I'll graph the second one. So I'm going to hit tab to put in my second graph, and I'll do cosine x. And then this one, remember, is -1, so we'll put that outside of the parentheses because it's a vertical translation. That matches what we have. And then our last one, so tab again to add the last one, and we'll do cosine. Now remember, in class we said it doesn't really matter if you're in radians or degrees, you can always zoom trig. In this particular case, it'll be helpful if you have it in radian mode because you're dealing with a translation that is in radians. So pi over 2 radians is our translation, okay? And so you'll notice that's our black curve, right? And it looks just like what we graphed. So ours is the blue one, okay? But if we go back to that, you'll see it looks like a sine curve, right? Because it's slid over the 90 degrees. And you can, sometimes it's helpful if you have the graph because you can see your traditional cosine, so you can use those other values to help you generate the curve.